Design of bolted joints, also known as the screw joints. The machine parts can be held together by means of a threaded fastening such as a bolt and a nut. This is a temporary fastening method. The parts can be dismantled if required without any damage to the machine parts. So thread is the basic element of these joints. The thread is formed by cutting the helical groove on the surface of a cylindrical rod or a cylindrical hole. The threaded element can take the shape of bolt and nut, screw or stud. The advantages: screw joints are highly reliable in operation. Screw joints are convenient to assemble and disassemble. A wide range of screw joints may be adapted uh, to various operating conditions. Screws are relatively cheap to produce due to standardization and highly efficient manufacturing process. Disadvantage: stress concentration in the threaded portion is high, and strength and efficiency is lower than the riveted and welded joints. The important terms in the screw joints. So pitch is the important term between the uh, same points on the successive threads. This is the pitch, and nominal diameter is the maximum diameter, and minimum diameter is the root diameter or minor diameter, and pitch diameter is in between the major and minor. Major diameter is also known as the nominal diameter. Stresses induced in the bolts. Stresses due to initial tightening. So in order to uh, join two things with the help of screws, so we may do it either by tightening the screw, or we may tighten the nut on the bolt. So that initial tightening will induce tensile stress on the bolt. The nut is tightened on the bolt gets elongated, that is subjected to tensile stress. So the initial tension in the bolt, based on several experiments, found that it is equal to 2840 D newtons. The above relation is used for making a joint fluid tight, like a steam engine cylinder covers. When the joint is not required as tight as fluid tight, the initial tension may be reduced to half, that is 1420 into diameter. The torsional shear stress caused by the frictional resistance of the threads during tightening. So from the torsion equation, T by J equal to tau by R, the shear stress tau can be calculated as 16 T by pi dc cubed. Shear stress across the threads. The average thread shearing stress for screw is obtained by the relation shear stress tau S is equal to P by pi dc into Bn, where B is the width of the thread section at the root. The average thread shearing stress for the nut is equal to P divided by pi d into Bn, where d is the major diameter or nominal diameter. Compression or crushing stress on the threads. It is a force P by pi by 4 d square minus dc square into n, where d is the major diameter and dc is the minor diameter. N is the number of threads in engagement. First category is initial tension, and second category is stresses in the bolt due to external forces. The bolt studs and screws usually carry a load in the direction of the bolt axis, which induces tensile stress in the bolt. So that force induced by the tensile stress is equal to pi by 4 dc square into sigma t. For n number of bolts, it is pi by 4 dc square sigma t into n. Shear stress. Sometimes the bolts are used to prevent the relative motion between the two parts, such as in flange couplings. The shear load carried PS is equal to pi by 4 d square into tau into n, where n is the number of bolts and d is the major diameter of the bolt. So when tension and shear both are combined, we will find out the maximum shear stress by the principal stress theory, and also maximum principal tensile stress. Stress due to combined forces, initial tightening and external load. Initial tightening is Pi and plus K into P2. Pi is the initial tension and P2 is the external load on the bolt, and A plus 1 by A, where A is the ratio of elasticity of the connected parts to the elasticity of bolt. The bolted joints are used for the eccentrical loading support also. Here in the diagram you can see there are four bolts which connect a plate to another bigger plate, and this plate is carrying or supporting a load P eccentrically. That means the load P is acting away from the geometric center of the four bolts. So this is called eccentricity. Due to the eccentricity or eccentric load, the bolts are subjected to two things. One, the primary shear, and another is secondary shear. Primary shear is equally shared by all the four, whereas secondary shear is uh, due to the rotation. So the bolt 1 is subjected to rotation in the clockwise direction, it goes upwards, and bolt 2 is subjected to downwards, and bolt 4 is subjected downward but towards left, and 3 is subjected to upwards but left. So in this diagram clearly shows all the four bolts are subjected to the primary shear, that is in the downward direction, whereas secondary shear due to the movement, some of them are in the upward direction and some of them are in the downward direction. So resultant of these primary and secondary on some of the or one of the volts will be maximum value, and that maximum value is considered for the design of the bolt. So by the visual inspection we can say that so the primary is in the downward and secondary is upwards but inclined in the bolt number 1, and in the bolt number 2 both are in the downward direction but with some angle, and the third one, one is downwards, another is upwards, and the fourth one both are downwards with some angle. That means the bolt number 2 and bolt number 4 can have the maximum resultant force. That maximum resultant force, uh, if it is maximum in one of them, then so that one is based on the design on which the design is based, and we are going to find out the diameter of the all four bolts based upon the maximum loaded bolt. So here this is the primary, and the secondary is calculated by the moment caused by the eccentric load P into eccentricity E, that is equal to uh, each one. There are four bolts, and in the four bolts P1, P2, P3, P4 are the secondary shear forces, whereas R1, R2, R3, R4 are the distances of centers of those bolts from the centroid G, and line joining to the centroid uh, is the radial line, and perpendicular to the radial line is the tangential line, and along the tangent you will have the secondary shear force. The secondary forces are also proportional to the radial distances, so that is on the part rather first bolt, it is It's proportional to the radial distance r1, and second is proportional to r2, third is proportional to r3, and the constant of proportionality is taken as c. So these are equal to cr1, cr2, cr3, cr4, like that. C can be calculated as c is equal to p into e by. So here P1 double dash, P2 double dash, etc. are replaced by CR1, CR2, etc. Already there is R1. So CR1 into R1, that is R1 square. Here it is R2 square. This is R3 square, R4 square. So C is taken out. So C is equal to P into E by R1 square plus R2 square plus R3 square plus R4 square, and so on. So by the way, you are going to calculate C. After calculating C, the secondary shear in the first bolt is calculated as this is C into R1. So this is C, which is P by R1 square plus R2 square, so on, into R1. Similarly P2, similarly P3, similarly P4, like that. Let us take an example. A steel plate subjected to a force 5 kilonewton and fixed to a channel by means of three identical bolts as shown in the figure. The bolts are made of plain carbon steel 45C8. Yield point is 380 Newton per mm square and factor of safety 3. Specify the size of the bolts. So we are finding out the diameter of the bolts. So first of all, the primary, all of them are subjected to 5 by 3. 5, that is 5000 by 3 is 1666.67 is the primary shear on all the three, whereas the secondary one is depending upon uh, distance of the bolts from the centroid of the rivet, the bolt system. So for the three rivets which are in a single row, the midpoint is lying at the center of the second bolt. So therefore, bolt 2 lies at the centroid. So therefore, 1 and 2 are equidistant from that at 75. So 1 is at 75 to the left of 2, and 3 is at 75 to the right of 2. So where 2 is lying at the centroid. So now uh, with the rotation, so 5 kilonewton is acting in eccentric direction towards right, so which will cause the clockwise moment. So the clockwise moment will induce the downward secondary shear on the down downward secondary shear on the third one, and upward secondary shear on the bolt one. So that means the primary in the first is in the downward direction, and secondary is in the upward direction, whereas on the second bolt the primary is in the downward direction and the secondary is non-existing because the radial distance is 0 from the centroid, and third one is in the downward direction. So it is uh, understood that bolt number 3 will be subjected to the greater resultant stress, so P1 and P3 are at equidistant, that is equal to P by R1 square plus R2 square plus R3 square, where R2 is 0, that is distance of the center of the second bolt from the centroid. So that's why it is removed, and R1 and R3 are same, therefore we are writing it as R1. So this is the value. So one is uh, primary is downwards and secondary is upwards. So therefore, from the visual inspection, we found that rivet number 3 will be subjected to primary shear in the downward direction, and secondary shear is also in the downward direction. So resultant shear force on the bolt 3 is equal to primary 1666 plus secondary uh, 10,166. Total is 11,833. Now we can find out the uh, diameter of the bolt from the load and area. So shear stress is given as 380 yield point stress, factor of safety is 3. Now you can find out the uh, allowable tensile stress as 380 by 3, and we also know that the relation between the allowable stress in tension is twice that of the allowable stress in shear. So therefore it is zero point 0.5 of 380 divided by 3, so that is 380 by 6, so it's around 63.3 Newton per mm square. That is allowable shear. So this allowable shear 63.33 is equal to total load 11,833 divided by the area pi by 4 dc square. Dc is 15.4, and from the dc, the core diameter, you can find out the nominal diameter dc by zero point 0.8, that is 19.28, or it is approximated to the nearest hand value 20 mm. So M20 is the standard size of the bolt which can be used for the given application. In the next problem, a steel plate subjected to a 3 kilonewton force as shown in the figure. Uh, The bolts are made of plain carbon steel with yield point 380 Newton per mm square. Factor of safety is 2. Determine the diameter of the shank. That is bolt. Now you can see that the centroid of this riveting system lies at the midpoint of the four rivets, and all of them are equidistant. All of them are equidistant from the center. The primary is 3 kilonewton by 4, that is 0.75 kilonewton, whereas secondary is uh, 1 and 3. 1 is clockwise upwards and 3 is also clockwise upwards, but 1 goes to the right and 3 goes to the left. But when you come to the second and fourth, the second goes downwards, that is right hand side, and 4 goes to the left hand side but downwards. So the angle is the angle between the primary and secondary is same. So then rivet number 2 and rivet number 4, both of them will be subjected to same amount of force, that is resultant force. Let us have a look at this. The primary is 0.75 kilonewton or 750 Newton, and secondary is all of them are equidistant. So therefore, PE into R1 divided by R1 square, R2 square, R2 square, and R4 square. This is secondary, and then the resultant shear force. The resultant shear force is calculated by uh, the algebraic summation of the two forces. Primary is 750 downwards, and whereas the secondary is 2.65 into 10 to the power of 3, that is 265 0 in this direction. The angle between them you can calculate, and two forces acting at a point with some angle in between them, you can find out the resultant by using the parallelogram law of forces, and that is the resultant force acting on the 4, and similarly you can find out the resultant force acting on the 2, and the larger value of these two. Generally both are having the same value because they are all equidistant and it is a symmetrical position of the rivets. Therefore, 2 and 4 will be having the same amount of maximum stress. Maximum of subjected to same amount of resultant force. So now from the resultant force, we can find out the diameter of the bolt. So from the 380 ultimate tensile stress with the factor of safety 2, and from allowable tension to allowable shear, it is ratio is 2. So now 380 by 4 is 95 Newton per mm square. So from the 95 allowable, uh, total force applied is P divided by area pi 4 dg square. You can find out D. From DC we can find out the nominal diameter. So 6.9 by zero point 0.8. So here in the next variety we move to the eccentric load perpendicular to the axis of the bolt. So in the earlier diagrams you can see the direction of the force is bolt is like this and direction of the force is like this. That means it is transverse in direction. So this results in primary shear in the downward direction and secondary shear is also in the downward or upward direction, that is in the same plane. Whereas in the next case you can see that you can see that due to the position of the load with respect to the bolts, uh, the primary will be shear when it is transferred from here to there. The primary will be shear, all right, but secondary will be pull. So that pull is calculated from the moment applied on the bolt arrangement. Here you can see in the first row there are two bolts, and in the second row you have two bolts. And when load applied here eccentrically with respect to the bolt system, the plate which is fastened to the main plate with the help of bolts will be tilting in this manner. The tilting will take place about an edge starting from C. So the corresponding you can see in the other view, this is the tilting edge. With respect to tilting edge, the centers of the second row is designated as L2 and center of the first row is L1. So when L1 is greater than L2, the moment caused by the force P on the first line will be greater than the second line. So the primary is same in all of the bolts here, that is load divided by 4, that is shear in nature, whereas secondary is tensile in nature, and in which the bolts at the maximum distance from the tilting edge are subjected to maximum amount of tensile stress. So that can be found out here. P into E is to tilt the bracket about the tilting edge with respect to C. This secondary shear is proportional to the distance of the rivet center from the tilting edge. So you can write, remove the proportion and replace it with constant. So secondary shear in the first is equal to C into L1, and secondary shear in the second row is equal to C into L2. So C can be calculated uh, like this. That is the total moment, eccentric moment, is P into E is equal to, so 2 rivets in the first and 2 rivets in the second, 2 into P1 into L1 plus 2 into P2 into L2. So we substitute uh, instead of P1 and P2, CL2 and CL1. So this is a CL1, CL2. So C is taken out and that is equal to PE by 2L1 square plus 2L2 square. 2 is taken out and that is P by 2 into L1 square plus L2 square. So after finding out the C, then you can find out P1 double dash, that is secondary shear, as PE into L1 divided by 2 into L1 square plus L2 square, and P2 dash is equal to PE into L2 divided by 2 into L1 square plus L2 square. So after finding out C, that C into L1 and C into L2 will give us the secondary shear in the uh, two rows of the bolts. So direct shear is load upon the area, and tensile is from the secondary uh, force, that is tensile in nature, and the tensile force by area will give us tensile stress. So because there are uh, two types of stresses experienced by the bolt here, and the maximum principal stress formulas should be used to find out the uh, failure stress, or the stress on which we are going to design the bolt. So there is one normal stress and one shear stress. So the major principal stress is equal to sigma 1 by 2 plus square root of sigma 1 by 2 whole square plus tau square, and tau max is square root of sigma 1 by 2 whole square plus tau square. And we will use this sigma 1, that is maximum principal stress is equal to yield point stress by factor of safety, that is allowable tensile stress, and this tau max is equal to the uh, yield point in shear divided by factor of safety. So this yield point in shear is half of the yield point in tension divided by factor of safety. So with this we are going to calculate the diameter. So here you can see a wall bracket is attached to the wall by means of four identical bolts, two at A and two at B, as shown in the figure. Assuming that bracket is held against the wall and prevented from tipping about the point C by four bolts using an allowable tensile stress in the bolt 35, determine the size of the bolts on the basis of maximum principal stress theory. So direct shear. So there are uh, total, how many bolts are there? Four. So it is P by 4, that is 6250, and shear stress is load upon the area, keep it aside. Then tensile stress in the bolts. So P1 double dot is equal to P by 2 into L1 square by L2 square, that is C into L1. So we calculate that as 11,270.49. We know that the bolts at the maximum distance will be subjected to maximum amount of secondary force, that is tensile force. So this is maximum because L1 is at the greatest distance from the tilting edge. So now the tensile stress is equal to tensile force upon the area, and then the principal stress in the bolt is equal to the tensile stress by 2 plus the root of tensile stress by 2 whole square plus tau square. So with this, we are keeping area as A, and finally we got 140.50, 14,050.62 by A Newton per mm square is the uh, major principal stress. So from that we are going to find out the area or diameter. So this must be equated to the sigma T max. So how it is given? The allowable tensile stress 35. So straight away it is given. So 35 is equal to 14,050 by A. So A is calculated as 401. So when area is 401, from the table, the design data book, you can find out the corresponding bolt size is M30. So here there are several problems given for the practice from the riveted joints, from the welded joints, and also from the bolted joints. So these are the various problems given for you to practice. Practice this and have good command over the subject. So thank you for watching, and let us meet in the next video.